Hello everyone. My name is ISHU, and today I am going to present you the my CWS project on of fundamentals and AIML course on urban heat island effect detection in Ahmedabad, Gandhinagar region using satellite data. Okay. So first, let's discuss what is urban heat island effect. So as you see here, the urban heat island effect refers to the phenomenon where urban areas experience significantly higher temperatures corresponding to surrounding rural areas. You can see from the diagram here, right? Uh, this is a rural area. This is the suburban area. Okay. So you can see here the temperature is much lower because of the tree shade and vegetation, right? But when you go here in the commercial area, downtown, urban residential area, okay, so you see the spike in the temperature. Why there is the spike? Because the heat is trapped between these buildings, these confined spaces, as there is less vegetation and more confined buildings, and those buildings might have glasses and all that stuff. So the heat would be trapped here. Okay, dark rooftops would retain heat, and that would lead to increase in temperature in this confined space region, right? And this even causes heating in in night. Okay, in night as well, urban heat island effect is shown. So you can see urban core retain heat for a variety of reasons, creating a heat island effect. So why it is being called as island? Because this is a kind of confined space which is getting heated due to urban architecture. Okay, so the main causes include urban architecture, removal of trees and vegetation, and high energy usage within confined region. You can see, for example, you can take Mumbai, right? Mumbai is near the coastal region. Mumbai had a lot of coastal forests cover and vegetation, which is being removed at a very large scale, right? And that is causing the average temperature in some areas of Mumbai to increase a lot. Okay, that's the prime example of urban heat island effect. Okay, and it is widely and this effect is widely visible in big cities and metropolitan cities, for example. Okay, so my project is urban heat island detection. Okay, so the libraries I'm using in this project is NumPy, Matplotlib, Rasterio, GeoPanda, and so on. Right. We all are familiar with NumPy and Matplotlib library. Rasterio is a library which is used to process HDF4 files and extract images from it. What are HDF4 files and how do we process them? I will tell you soon. Okay, GeoPandas is another library which is used for geospatial analysis, uh, for geospatial analysis. For example, you can take it works with shape files and helps in creating boundaries in files, right? Then another library is SciPy. Everyone is familiar of it. OS is another library we are using here. OS library deals with the path and directories and all that stuff. Torch and its libraries. PyTorch is being used here to define CNN model, convolutional neural network model, and to train the model and deduce the results. Right. PIL is another library which specifically deals with images of the form PNG, JPEG, etc., etc., and they are helpful in uh, various types of training models, right? Another library is scikit-learn. Everybody knows about it, and the other library is Folium. Folium is a library. It is a very special type of library which you can directly import, and it is used for the visualization in interactive maps. Okay, and another one is Shape, SHAP, and it is used for many different cases. Right? So yeah, let's consider the sources of dataset which I use. So the source of dataset is this website. It is known as MODIS Search Earth Data website from NASA, right? Here uh, I downloaded HDF4 files from the duration 1 May 2024 to 31st July 2024. The reason why I took the year 2024 is because NASA's website uh, has stopped updating because of lack of federal funds and all that stuff. Okay. Other thing I took as a source of dataset is the shared files of Indian states and districts from JDM website, which I used further in my script to mark the boundaries in the images I extracted, right? So let's go with the project workflow. So I have two Python notebooks in which the whole project workflow is there. So the first Python notebook does this work. Extraction of Ahmedabad Gandhinagar Inferno heat map image, right? So first what I did, I downloaded LST HDF4 files from Modis website. FYM1A1, this is the satellite which satellite image name, kind of that only. So LST is land surface temperature. Land surface temperature is the main factor from which we can analyze urban heat island effect. Okay. So took the data from 1 to 37, used Rasterio and all this stuff. So what is HDF4 file? HDF4 files are those files which have a lot of information in different sub informations, right? So we want to generate satellite images from that. So that's why we use Rasterio. Okay, Rasterio is very helpful to process HDF4 files and generate satellite images from that, and then so on and so forth. You can see the whole process how I am doing. Use shape file from GDM website, right? And then mask those files into the heat map generated images to superimpose the boundaries, right? And then zoomed into the Ahmedabad Gandhinagar region as it is the it is the main region for where we have to do the analysis, right? Now then I finally downloaded this image in a separate folder to do my further analysis, right? And second this is the workflow of second Python notebook. Okay, preparing the image data which was prepared, then data was split, model was developed, and CNN was created and trained. Okay, then performance evaluation matrix were calculated and geospatial visualization was done. Okay, so let's continue with the first Python notebook, that is extraction of Ahmedabad Gandhinagar Inferno heat map image. Explain to some of the core scripts. So you can see from the script here, right? First we have simply imported these three libraries, and then this is a file we have put the location here, file path. Okay, yeah, I was saying earlier that is sub dataset, right? So sub dataset HDF4 file is that file which contains many sub datasets which contains many info. So I wanted that sub dataset file which contains the image of LST of day of a particular day. Getting my point? That means in HDF4 file I was supposed to extract the sub dataset file which was image only. Okay. So I with Rasterio open as source, I wrote this. I read this file one. One is the first sub dataset and the first sub data set was the most useful for us. Okay. Then after when the image was processed and formed, okay, so it was showing the temperature in the order of 10,000s of Kelvin. Okay, so I had to convert it into Celsius. So that is the simple and so that is the simple conversion from 10,000s of Kelvin to Celsius multiplied by 0.02 minus this. Okay, and uh, simply I put NaN values to those data in that file which has absolutely zero value. Okay, and then I just plotted the graph, title, axis, color bar, and the color which I used was Inferno, because Inferno is probably the most accurate accurate type of CMAP color when it comes to analyze the LST satellite images, right? So you can see here the MODIS LST daytime 1 kilometer satellite is a MODIS satellite SDF file from which the Python code is intended to process, extract, and display land surface temperature data. Okay, that is now this is the second code snippet. Now I will go fastly. Okay, so we imported GeoPandas and other libraries, and again we did the same here, right? Again we did the same. Now, yeah, and here again we did the same. Now what I did afterwards, I downloaded from a website called JDM, and I downloaded shapefile of India which contained its boundaries, the boundaries of its states and as well as districts. Okay, so I just downloaded and put that file path, and then I read the file using GeoPandas syntax. Okay, after that I filtered Gujarat from it. Okay, yeah, so by the way, this image tile which I have took from NASA's dataset, it only contained region from Rajasthan, Gujarat, and parts of Pakistan. So that's why I did the analysis on Ahmedabad, Gandhinagar region, because in this region probably the biggest city is Ahmedabad, Gandhinagar region, right? Okay. So yeah, we did filter Gujarat here. Okay. So this code loads land LST data from an HDF file, extract the daytime temperature layer, converts it into Celsius, and overlays it on a map of Gujarat district using shapefile boundaries. Okay, and afterwards we reproject this. Okay, and then we created plots, right? And yeah, we also put district names. The main thing to observe here is that we wrote the name of that district in the centroid of that district area, district boundary, right? Okay, and then finally we plotted the curve. And another thing to observe that we masked both shapefile and this image file so as to superimpose the boundaries and names of districts in Gujarat state. Okay, yes. So this was some part of this, right? I will show you the last code snippet of this Python notebook. Okay, so you can see here from what I was saying, this was LST, and right, we have converted into degree Celsius. This was whole area which was covered by the satellite image. Yeah, one thing to observe here, you might be saying that this this temperature is incorrect, right? Or you might be saying why is this isn't recorded. So we see that when the satellite image is captured, sometimes the clouds come over. Okay, so these are the clouds which obstruct the view of capturing the land surface temperature by the satellite. So this is that part only. Okay, So these are the code snippets. Yes. Now simply next I simply did did cropped and zoomed the Ahmedabad Gandhinagar region here, right? So what I did, I loaded. So these are the same things. Again, I did the same stuff. Loaded shapefile as well this time. Downloaded earlier, right? And reprojected them. Okay. Now using this, now using syntax of GeoPanda, I filtered out Ahmedabad and Gandhinagar region. Okay, and then used Inferno CMap and plotted this Ahmedabad Gandhinagar region, right? And again, I did this centroid stuff, writing the name in centroid, and zoomed into the Ahmedabad Gandhinagar region by adjusting the pixels, not pixels exactly, extending ex, extending the padding, right? And then I added the temperature scale, right? So yeah, finally what we've got this, right? So this is the Ahmedabad Gandhinagar region. It contains Ahmedabad, Gandhinagar, Dehgaon, Kalol, Sanand, Virangam, Dholka and Dhanduga. Okay. So this is the main file for which we would do the further training of training of CNN model and analysis. And final analysis would be based on these set of images only. So my folder contained 92 HDF4 files. So I simply wrote the path code to simply download all the images here, right? So these are the files. I can explain in short here, right? Okay. So these are the 4 paths I wrote here. Make directory, loaded shapefiles. Again, Gandhinagar Ahmedabad region were filtered, right? And then I looped by using OS properties and listed directories, right? And simply then loaded 4 and then simply I put the loops, right? Loaded sub dataset again, and invalid pixels were cleared here, gaps were filled, okay, and finally all the stuff was done here, right? Padding was done, labeling was done, okay. So you can see here how were all the files have been saved into a different folder, right? I hope you got the point in this case. Okay, you can see here, right? Now let's proceed further. Before going to that second Python notebook, which would be very easy, we would discuss what is CNN. So this is the input file, which is an image. It has a lot of kernels. Okay, kernels contains the features of that image, right? These are the and then now these are the convolutional layers, right? So this is one convolutional layer. First, this feature goes into here, right? So what this convolution this it filters out the main feature, right? And then it goes here, goes here, goes here. So pooling, what is pooling? Pooling is simply that feature which kind of extracts the most important feature. Okay, it's that property which in which the most important feature is extracted, right? And here the principle used is ReLU. So ReLU is simply a function which behaves as x. I mean, ReLU of x is equal to x if x is positive, and is equal to 0 is x is if x is less than 0, right? So if x is positive, all the data, all the feature would be proceeded further. If it's negative, it would be dropped here, right? And then finally, what we do, we finally flatten this layer and convert it into a 1D vector, this whole information, and using connected layers and class of classification, we finally get a probabilistic distribution, and using other functions such as softmax activation function, we predict the output, right? So if we see if the max probability output would be considered as the final answer, the most predicted one. So zebra would be predicted here because the probability of getting zebra is zero point 0.7. Okay. So Python, so the second Python notebook is splitting of dataset, training to CNN, final workflow, which I would explain in my code. Okay. So this is the code. So I would not explain line by line, just go, I will just do an overview. So these are the libraries which were imported: OSTorch, PyTorch, PIL, NumPy, sklearn, matplotlib. Then drive was mounted, right? Then we define a heat map dataset. So it is basically what it is. This is defined to get the paths of, get the directories of the images which we have to process for further training, right? Okay, so you can see from the code here, we define this. Okay, we transform this image, then we load and clean the image, we remove all the cloud and whitey spots, and then we define which intensity we have to consider for further analysis. If average red is less than 85, so the label would be 0, cool. If it is this, it would be label 1, which is moderate, and if it is this, the label would be 2, which is hot. Okay, and then we would apply an extra transformer, right? Okay, for yeah, okay. Now what we do next, we simply define, we simply split the data into three parts: 0.7, 0.2, 0.1 ratio. Okay, out of 1. Okay, so the total data set was of 92 files. So if you multiply it with this factor, you would get this training data set, validation data set, and test data set values, how many files are there in them. So it would be 64, 18, 10. You got it. The length of the file, length of that folder, right? LEN. Okay. Now what we do here, we train, this is the part main. This is the main part. We train the CNN here, right? So we define init self function, and then we train the CNN with two simple convolutional layers and pooling in first case. Okay. And then it would figure out its flattened size automatically, right? And then we would classify. So it would, so the convolutional layer used there is very simple, right? So we use this model, right? And then we used CUDA for training, and if no, CUDA is not available, so CPU would be used to train that CNN model. Okay. So now we use some criteria. So first criteria is NN cross entropy loss. So the criteria which we use to train this model is cross entropy loss, and the optimizer uses Adam model with LR is 0.1. LR is learning rate, on how big the steps should be when learning. Okay, And Adam is one of the most popular optimizers. It's fast, stable, and works well much without tuning, right? Okay. Then we train the model. We consider the epoch to be 5, right? And yeah, in this line, the model itself back propagates as well. While back propagating it, uh, it simply removes all the errors it has, right? And so on. We then calculate the accuracy. We get it as 90%, and then we find the metrics, evaluation metrics, metrics, that is precision, recall, F1 score, and support, which we got this as this, and we simply plot. Then we simply plot this confusion matrix, right? So here we get this. Okay, and in this line, finally, after doing all the stuff, we simply plot the heat maps which were finally predicted. So here, what I did, I I masked that cloudy region to black. Okay. So in some images, the whole extracted image was white. So it was converted to black. The reason was it was whole cloudy. It was a whole cloudy in the sky. That means it was probably the season of monsoon. In this case, so it predicted cool. This was the time of approximately June. So it predicted moderate. It predicted cool, cool, moderate, cool, cool, and again moderate. So these were the cloudy areas, right? And then finally, I used the Folium. Folium is the interactive environment to get the maps, to get the geographical maps, right? So then I saved this. So I considered the coordinates of these cities and then did intensity mapping, right? So I can run this. And after that, I saved that final file as an HTML file to simulate, right? Which you can see in my drive link, which I will share to you. Okay, so you can see here from here, you can download that HTML file. Okay, I will share differently as well to it. So that's how we can use that. So that's how we can use CNN techniques to find to detect urban heat island zones, and we can also improve in many places, like we can use more advanced model techniques, probably ML techniques, DL techniques, to even predict more precisely and accurately, and then we can detect the urban heat islands in cities and take necessary actions. These this this interface can be integrated to government's website as well for great social work. Okay, so that's how I wrap up my presentation. Thank you very much.